go. Section 3.3, Quadratic Functions. Says a quadratic function is a polynomial of degree 2. We've been talking about polynomials in the past of degree 1. Those are linear, but with degree 2 now. It says the graph of a quadratic is a U-shape called a parabola. Parabolas can open upward or downward, and we'll learn later on they can open to the right and left. The maximum or minimum point is known as the vertex. All parabolas are symmetrical. We call the line of symmetry for a parabola the axis of symmetry. The line always passes through the vertex of the parabola. Hopefully all stuff that you remember from previous classes. Anything of degree 2, and this is what the basic form is going to look like. Y equals ax squared plus bx plus c. Anything that we graph like that is called a parabola. What it's saying is parabolas either are cupped up, they're concave up is the word we used before, or they're concave down. Parabolas have a vertex, which is either the very lowest point on the parabola, or if it's cupped concave down, it's going to be the highest point. All parabolas are symmetrical, which means they're mirror images left and right of each other. They're symmetrical across the what's called the line of symmetry. So the dotted line there that I just drew is called the line of symmetry. See if there's anything else I missed. I believe that's all of it. There are 3 basic forms of a parabola. We did all these in Algebra 2. Again, there are 3 forms that we can write the equation of a parabola. The first one is the one I just showed you. It's called the polynomial form. And what we're going to do is we're going to go through the 3 forms and show you, okay, what's the best way if it's written like this to find the vertex, what's the best way to find the x-intercepts, what's the best way to find the axis of symmetry and all that. Polynomial form is the form I just had it in, and that's the form you see it in most often. It says in polynomial form we can find the x-intercepts by using the quadratic formula. Again, to find the x-intercept, what if something did look like it? What if we had y equals x squared plus 6x plus 7. How do you find the x-intercepts of anything? What do? How do you find x-intercepts? You plug in 0 for y. That's what I was looking for. Always plug in 0 for y, and then you just solve the equation to find your 2 x-intercepts. And that's going to be one of the main things we're looking for. So you would do 0 equals x squared plus 6x plus 7. And once you had it in that form, that's what it's saying. Go back to it. It says in polynomial form we can find the x-intercepts using the quadratic formula among other methods. We know the other methods. We could factor, we could complete the square, we could do graphing. So we can also find the x value of the vertex using the following formula. This formula is important to us. X equals negative b over 2a is the x value of your vertex. To where b is obviously there. It's whatever's in front of the x, and a is whatever's in front of the x squared. And I'm going to talk about all these, and then we'll go back and pull it all together. And this is all in your notes. Transformation form. This is the reason I did transformations first. Transformation form says we can change the we can change from polynomial form to this form by completing the square. So polynomial form's up here. If we want to get it in transformation form, we complete the square. In this form, we can easily identify the vertex based on translations. We can also easily identify any reflections, stretches, or compressions. Because, well, let's talk about it. What's your parent function? From your for y equals a times x minus h squared plus k, what's the parent function there? X squared. That's the most basic parabolic or most basic quadratic form. Well, let's talk about how you would actually find the vertex. If you had x minus h, what's that minus h? Or well, if it's like x minus 3, what would that minus 3 do to it? It'd move it right 3. It'd take, in y equals x squared, the vertex would be at 0, 0. If you move it right 3, and then what if you had a plus 2 attached to the end? It'd move it up 2, so you could see that your vertex would move right 3 and up 2, and now be at 3, 2. So it's very easy. This HK actually identifies your vertex. The A out front. Normally, y equals x squared, need to know this, y equals x squared looks like this. It does have a vertex of 0, 0, passes through the point 1, 1, 2, 4, 3, 9, 4, 16, passes through those points. But what if we had a negative out in front of it? Let's go back to that. What if A was a negative value? Transformations, that would flip it up and down. It would flip it across the x-axis, then it would be concave down. What if A was a number like 3? What would it do? It would stretch it vertically times a factor of 3. It'd make it skinnier. If it was a number like 1/2, it would compress it vertically by 1/2, make it shorter and fatter. So that's your transformation form. Hopefully you can see where you would use transformation form. You can see the movement, you can see the different transformations taking place. The final form is the X-Intercept form, or I'm going to call it the factored form a lot. It's not always going to look exactly like this. You could factor it down to where it does, but most of the time I just factor and leave it. I sure will. X-intercept form says this is simply the factored polynomial form. We can easily identify the x-intercepts of the parabola using this form. The x-value of the vertex can also be found by averaging the two intercepts. Let me explain what I mean there. So it says the x-value of the vertex can be found by averaging the two intercepts. Let me show you what I mean by this. Your x-intercepts. Okay, here and here. Factored form, those are really easy to find because if it was x minus 3 times x plus 4, your intercepts would be 3 and negative 4. If you wanted to find the vertex, before I gave you that formula, negative b over 2a, but if you have the two intercepts, you notice the vertex, since it is symmetrical, the x value of the vertex will be directly in between those two. So what you can do is add them together. That's going to be negative 1 divided by 2, average them, and you get negative 1/2. That's going to be the x value of your vertex. That's going to be your axis of symmetry. So that's another method you can use. All of this is just showing you pretty much 3 different ways of doing the exact same thing, all depending on what it looks like. It saves time if you know all 3 ways, because then whatever the equation looks like, there's an easier way to find it based on that. Note, in all 3 forms, if a is negative, the parabola is reflected across the x-axis and concave down. So a positive a, hopefully you remember that from last year. Positive a is concave up, negative a, concave down. Example 1, find the concavity, vertex, and intercepts of each quadratic equation. Doesn't say how. So x squared minus 6x plus 8. Y equals x squared minus 6x plus 8. Says find concavity. Let's do that first. Ax squared, is it positive or negative? So it's going to be concave up. Next up says to find the vertex. Since it's in this form, the easiest way to find the vertex is using that formula, negative b over 2a. So therefore x equals 6 over 2, which is 3. But the thing about it is the vertex is a point. Is that a point? That's half a point. Therefore, in order to find the other half of the point, because your vertex, now I'm just going to put v in front of my point here. Your vertex is going to be 3 something. Anytime that you want to find the other something that goes along with it, plug it in. So you have 9 minus 18 plus 8. So therefore your vertex is at 3, negative 1. Good job. And let's see, lastly it asks us to find the intercepts. The easiest way I think to find intercepts is always factoring if possible. But to find an x-intercept, we're plugging in 0 for y, so we now have x squared minus 6x plus 8 equals 0. What's that factor into? Negative 4, negative 2, so what's our intercepts? X equals 4 and x equals 2. Let's check something I told you a while ago. I told you the x value of the vertex is always between those two intercepts, is it? It's the average. 4 and 2, if you average those, you get 3. Could we have found these first, and then without even using the formula, found the x value of the vertex very easy? Yeah. Either way you would like to do it. Here we go, next problem. We're asked to find the exact same thing. We're looking for your concavity, we're looking for the x-intercepts, and we're looking for the, what was the third one, vertex. First off, concavity is easy. This is concave down because the a value, whatever's out front, is a negative. That's all you got to do there. Concave down. It's cup down. Let's do this next. Let's find our x-intercepts next, and just that way we can do our vertex two different ways. Find your x-intercepts. You set y equal to 0. Good. So equals 0. Since you have a number out front, when you go to factor this, you've got to say what adds to give me -1, multiplies to give me one word. What are you going to use this to do? Once you find the split. What is the number? Good. -4, 3. Let's split the negative x. So -2x squared, -4x plus 3x plus 6 equals 0. Group. And leave x plus 2. Pull a, and it leaves you with, and obviously that's right because we have x plus 2 in both. So x is -2, x is, careful there, positive or negative? Positive 3/2, because when you move the 3 over it becomes -3. When you divide by -2, you got negative divided by negative, which is a positive 3/2. So x is -2, x is positive 3/2 is your x-intercept. Okay, again we have two different options here for finding your vertex. Thank you. First option is we could average these two x-intercepts. Honestly though, that's probably not going to be the easiest way, because you look at -2 and 3/2, you're going to add those, divide by 2. It's going to be a little bit easier just to use your formula. Your formula is x equals -b over 2a, which would be x equals -b. What would be -b? 1. 2 times a would be -4, so -1/4. You can put that negative in where you want. Is the x value to actually find the y value? What do? So I'm going to take, and up here, the vertex is equal to -1/4, comma. Let's plug that in. We've got, so we're actually find g of -1/4. So you have -2 times what? 1/16. You got to square it. Minus -1/4 would be plus 1/4 plus 6. -2 times 1/16 will be -2/16, which will be -1/8. Plus, go ahead and change that to eighths. 2/8 plus 6. 2/8 minus 1/8 is an eighth, plus 6 is 6 1/8. There's your vertex. Okay, the next problem says write each equation in transformation form and then find the vertex and intercepts. We're doing the exact same thing. Okay, except we're going to do it from transformation form now. So y equals x squared minus 6x plus 8. Transformation form. Again, to change it to transformation form, what do? Complete the square. Instead of f of x, just to make things a little bit simpler, I'm going to write that as y. First step of transformation, or first step of completing the square, move over 8. Move 8 to the left side. We now have y minus 8 equals x squared minus 6x. Okay, we don't have anything in front of x squared, so now we're just completing the square. Take half the middle term, or take half the x term and square it. You're going to add 9 to both sides, so you got y minus 8 plus 9 equals x squared minus 6x plus 9. Anytime you're completing the square, the next step will always be factor. So, clean that up. This is going to be, if you don't remember, this xx, -3, -3. It should always factor into the same thing. That's it. It's the half of that middle term is what it's always going to factor into. So let's write that as x minus 3 squared instead of x minus 3 times x minus 3. And then last step, minus 1. So we have x minus 3 squared minus 1. Again, that's called transformation form because your parent function, y equals x squared. But we've changed it. Vertex, first thing. So the minus 3 moves it to the right, 3, and the minus 1 does what? So if we started, normally y equals x squared has a vertex at 0, 0. So it looks something like this. But if you take that vertex, you move it right 3 and down 1, where's it at now? Vertex is at 3, -1. You can check your notes. That's what we found last time as well. What else did it ask us to find? The intercepts. Let me show you how to find the intercepts. And you might like this better. Finding the intercepts from this point, you don't have to factor. Because how do you find the intercepts? You plug in, what do? How do you find the x-intercept? Plug in 0 for y, so now you have, and this is finding intercepts, 0 equals x minus 3 squared minus 1. We're finding the intercepts now. This is easy to solve. Because don't sit there and multiply this out and combine like terms. Don't do that. Okay, anytime you have stuff squared minus 1, what we're going to do to solve that, move the minus 1 over. Have 1 equals x minus 3 squared. Do you need to FOIL that out now? No. How do you get rid of the squared? Square root both sides. When you do the square root of 1, though, it's not 1. It's plus and minus 1. Don't forget, when you square root both sides, don't forget to put your plus and minus in front of it. What's the right side now? Last step. So x equals 3 plus and minus 1. So x equals 4 and x equals 3 minus 1 is 2. Makes sense. Which you can look back again, that's the same answers as you got before. Once it's in transformation form, it's pretty easy to find everything. Because you don't have to factor, you don't have to use any formulas. You can just look at it, well, there's what happens with my vertex. Set the y equal to 0, there's going to be my x-intercepts. So vertex form is pretty easy to work with. Okay, we're asked to find the exact same thing on the next problem. We are going to complete the square. This is not going to be very much fun. We did the last one too. We're doing the same thing, different way. We're going to change it to transformation form. Again, first step's the same. Move the 6 over. We now have y minus 6 equals negative 2x squared minus x. Here's the part you might not remember. If there's a number out front, you've got to get rid of it. The way we're going to get rid of it is by dividing everything by that negative 2. Okay, this is no fun. So I'm going to write this as y minus 6 divided by negative 2 equals, divide that by negative 2, you have x squared. Divide this by negative 2, that's going to be a positive x over 2, or 1/2 x. Ugly. Very ugly. Yeah. So we're going to have to take half middle term, square it, which that's pretty easy. Half of 1/2 is a 4th. Add a 16th to both sides. So you have y minus 6 over negative 2 plus a 16th equals x squared plus 1/2 x plus a 16th. And I might have done this a little bit different this year, or from last year. So here we go. What we're going to do now is we're going to factor, and again, I might have done this a little bit different last year. I can't remember. Honestly, let me tell you straight up now. This type of problem, number out front, I wouldn't solve by completing the square. That'd be the last method, because that's the ones that end up nasty like this. So you've got y minus 6 over negative 2 plus a 16th equals x. That's pretty easy to factor. It's always, like I said, half of this term, so x plus a 4th squared. Bless you. Now we got 2 more steps. We're going to move the 1/16 back over. Y minus 6 over negative 2 equals x plus a 4th squared minus 1/16. You add a 16th to both sides. Whatever you do to one side, you got to do it to both. These. Whatever you use to complete the square, you halved and squared. You factor. Okay, the last step we're going to get rid of that divided by negative 2. We're going to move it back over 2. So you multiply both sides by negative 2. That's, I forgot about the negative 6 up there, so we're going to have one more step. We're going to multiply both sides by negative 2, so you have negative 2 times this. And then negative 2 times 1/16 will be a positive 1/8. let me go ahead and do this last step. Move the 6 back over, you get y equals negative 2 times x plus 1/4 squared plus 6 1/8. Okay, now that we've got it in transformation form, it's easy to find the stuff. We know first off, which we don't have to tell, it is concave down because you got the negative 2 out front. The vertex, normally at 0, 0, this has been transformed. You moved it, since the plus 1/4 is in there with the x, you're going to move it where? Left 1/4. You got the plus 6 1/8 out at the end, so you're going to move it up 6 1/8. You can look back, that's your vertex from before. The other thing it's going to ask us to do is to find the x-intercepts. And I'm not going to go through the whole process of this just because of time's sake. To find the x-intercepts, you would plug in what? 0 for y. So you'd have 0 equals negative 2 times x plus 1/4 squared plus 6 1/8. I will tell you the steps you'd use to solve it. You'd move 6 1/8 to the left side. You'd divide by negative 2. Then take the square root of both sides. Make sure you do plus and minus square root. And then the last step is move 1/4 over. So you have negative 1/4. So there's your problem there. Okay, the next example says write each equation in x-intercept form and then find the vertex and intercepts. We've actually already done that. Because x-intercept form is simply factored form. If you go back to that first example, we factored both of those. Like the first one would be f of x equals x minus 2 times x minus 4. That's factored form. Not really interested in you knowing about x-intercept form, but we use x-intercept form mainly to find your intercepts. So with that said, let's skip down to example 4. It says write each equation in polynomial form. These are written, the first one's written in an x-intercept form, the second one's written in our transformation form. So how are we going to go from there back to polynomial form? You just FOIL it out, multiply it back out. So the first problem, let's write it down, 2 times x minus 1, x plus 6. Y equals. Which I don't know why we'd want to go back, because to me factor form works better. Because look at it, what's going to be your intercepts there? 1 and negative 6. We could actually find our, see if you can do this, our x value of our vertex. Since those are nice, neat whole numbers, can anybody tell me what the x value of your vertex is going to be? Negative 2.5. I think somebody said that. Add the 2, divide by 2, average them. Because if you've got a parabola, there's your x-intercepts, your vertex is going to be directly in between it. So it would be negative 2.5. But let's go ahead and write that in the form they want. Multiply 2 at a time. I'm going to leave the 2 out front and multiply x minus 1 and x plus 6. X times x, x squared. X times plus 6 is plus 6x. Negative 1 times x is negative 1x. Negative 1 times 6 is negative 6. Combine these, we get 5x. So y equals, go ahead. Plus 10x. That's now in your other form. If you want it in this form, if now I wanted to find the intercepts, you could use your quadratic equation. Okay, you could do negative b plus or minus squared. You could plug all that in to find your intercepts. Easy way would be to factor it, but that's carrying you back up here. To find your vertex, you could use x equals negative b over 2a now. Makes sense. All depending on what form it's in is the method you would use. Next one says 3 times x plus 3 squared minus 3. And I'm putting y equals instead of g of x or whatever. Vertex, easy to find in this form. So again, I don't know why we would be going back to the other form, but just in case you need to, what would be the vertex there? Negative 3, negative 3. Would it be concave up or down? Up, because there's a positive out front. Let's see, what else could we find? Intercepts, if I wanted to find the intercepts, set it equal to 0, move 3 over, divide by 3, square root both sides, move the 3 over. But let's go back to the other form. So we got 3 times x plus 3 squared. See if we can do that in our head. What is x plus 3 squared? Good job. X squared plus 6x plus 9 minus 3. 3 times that would be y equals plus 27. Then we got to do the minus 3, so I'm just going to erase that so I don't have to rewrite it again. 24. Again, in that form, we could factor it to find our 2 intercepts. We could use quadratic formula. Find our 2 intercepts, we could write it back in this form to find our 2 intercepts. Vertex, we could use x equals negative b over 2a. That's an important formula. Need to know that one. Let's see. Next up, got 2 word problems. And again, this is the whole purpose of this, is being able to work word problems. It says a field bounded on one side by a river is to be fenced on 3 sides to form a rectangular enclosure. If the total length of fence to be used is 200 feet, what dimensions will enclose the maximum amount of area? Again, this is where you're going to see most of these parabolas, is when you're maximizing or minimizing stuff. So again, we got a field that we're going to fence in. It's got a river on one side. There's the river. We're going to fence this field in. Okay. Let's see. It tells us that there's 200 feet of fence. 200 feet of fence. And it says we want to maximize area. We want the maximum amount of area. So we're only fencing in, so it makes sense we're only fencing in this side, and this side. That's the whole thing about the river, because we don't have to put a fence there. We just want to fence in the field. We got 200 total feet of fence. Watch how I define my variables here. We're going to let this be my unknown. This would be the same width, right? Now the problem is, what would that be? There's 200 total feet of fence. Well, how much are we using here? X and X. How much is that? 2X. Okay, whatever we're using there, we're not going to be able to use here. So if there's 200 total feet, what if we used 100 on the sides? We have 100 left for the front. What if we use 50 on the sides? There's 150 left for the front, right? So how are we going to write that in terms of X and X? Excellent. 200 minus 2X. Good job. We want to maximize area. Want to maximize area. How do you find the area of that? Length times width. And we're going to let that be, we'll call it A. A equals X times 200 minus 2X. Any questions? Think about what the graph of that would look like. It's a parabola, right? Because if you multiply that out, A equals 200x minus 2x squared. With me? Can you tell me if it's concave up or down? It's down, because of the negative 2 in front of x squared. So it's going to look like this. That graph represents what our area is, correct? And what do we want to do with our area? Find the maximum area. Where's the maximum area occur? At the very top. What's that called? So all we're doing is finding the vertex here. When we're maximizing area, we're looking for the vertex. So the easiest way, I think, since it's in this multiplied out form, let me rewrite that with the stuff first. Negative 2x squared plus 200x. What do you feel? Well, I might have told you. I can't remember what I just said. What's the easiest way to find the vertex in that form? Plug what in? How can you find the vertex when it's in that form? You don't have a c out here, plus 0. That's in that polynomial form, that first form. Good job, Christina. Negative b over 2a. That's the vertex. So the vertex is going to be negative b, which is over negative 4, which is 50. So we're going to let x be 50. So that's going to be 50. This is going to be 50. And what's this side going to be? 100. That's going to maximize the area. Now what would the area actually be? If I ask you that, x equal 50 maximizes the area, but what is the area actually equal to? 5 5,000 feet squared. So the dimensions that would maximize area would be 50 by 100, and the maximum area would be 5,000 square feet. If you did 49 by 102, you would see that that would be right here close to the maximum, but not quite. This would be 49 by 102. This would probably be 51 by 98, something like that. But the one that maximizes the area, the one that's on the top there, is the 50 by 100. A potter can sell 120 bowls per week at $4 per bowl. For each 50-cent decrease in price, 20 more bowls are sold. What price should be charged to maximize revenue? Okay, what we're going to do again is we're going to looking at the problem, says a potter, again, can sell 120 bowls for $4 per bowl. Each time we have a price increase, he's selling more bowls. He's selling 20 more bowls per price increase. And each time we have a price decrease, we also go down 50% in price. So that's going to be our unknown. So we're going to say let x equal number of price decreases. Therefore, let's see, we've got the bowl sold here, and we've got the price here. Okay, bowl sold. Normally he sells 120, but if he has one price decrease, he's going to sell 20 more. If he has two price decreases, he's going to sell 20 more than that, or 40 more. So it has three price decreases, he's going to sell 60 more. So he's going to sell 120 plus 20 more for each price decrease. Makes sense. One price decrease, he'll sell 140. Two price decreases, he'll sell 160. Three price decreases, he'll sell 180. Now the actual price. Normally the price is $4 a bowl, but each time he has a price decrease, it goes down 50 cents. So it'll be, good job, 0.50x. So $4 minus 50 cents per price decrease. Now the actual revenue. Here's where our function comes into play. This is how many bowls he sells. This is the price that he sells it at. How do you normally find out how much you're making? Like, let's say I sold 10 bowls for $4 a bowl. How much money did I make? $40. You multiply the two. So the revenue, I'm going to call it just R, is equal to 120 plus 20x times 4 minus 0.50x. The revenue is equal to the number sold times its price. We want to maximize revenue, right? Why would we want to minimize it, right? We're maximizing revenue, so I'm gonna multiply that out. Here's another strategy, though. We're looking for, again, if you multiply this out, it's going to be like this shaped parabola. I think I'm going to use this method. I think it's going to be a little bit easier. Do you see how easy it would be to find your intercepts? Because you have something times something. So it would be really easy to find those two intercepts. And what did we say was true about the vertex in relation to the intercepts? It's in the middle of the two. So what I'm going to do is I'm going to take these two things and I'm going to find my x-intercepts. The way that you do that is you say 120 plus 20x times 4 minus 0.50x equals 0. What's going to be my first x? Negative 6. What's going to be my second x? You got to move the 120 over, divide by 20. You get negative 6. This would be, let's see, you've got to move the negative 4, divide by 0.5. Divide by negative 0.5. It's dividing by negative 1/2, multiplying by negative 2. That's going to be a positive 8. So therefore my intercepts are at negative 6, which I didn't draw that scale. Negative 6 and positive 8. Where's my vertex going to be? It's right in the middle. So add the 2, divide by 2. Divide these. That's where my x-intercepts are. Negative 6 and positive 8. This is negative 6, this is positive 8. The vertex is directly in between those, which is 1. That's not drawn to scale. Negative 6, positive 8 would actually be more like that, would be my origin. So therefore, if you add the two, find the average. Negative 6 plus 8 is 2. Divided by 2, you get x equals 1. Okay? That's your maximum point. So to maximize sales, we're going to have one price decrease. How many bowls will you sell? 140 bowls will be sold. And what will be the price of each? $3.50 because you had one price decrease. So if you want to know how much money you actually made, 140 times 350, that'd be 420 and 70, $490. So one price decrease will give you a profit of $490. Something else you could do to solve this problem is you could do a trial and error. You say, well, what if I had 0 price increases? And let's look at it that way. 0 price increases, how many bowls would you sell? 120. How much would be each bowl? 120 at $4 would give you a profit of $480. How much did we make with ours? $490? Yeah, I believe so. $490. So that would be 140 bowls at $3.50 a bowl, gave us our $490. If you had 2 price increases, how many bowls would you sell? 160 bowls at how much? 160 at $3, which would give you $480. Do you see the parabola shape there? No price increases, you're at $480. 1 price increase, you're at $490. 3 price increases, you're at $480 again. If you did another price increase, that'd be $180 at $2.50, which would be $360 and $90, $450. Okay, and if you kept on having price increases, you're not going to make as much money. So to maximize profit, 1 price increase.